So here's the constant of proportionality foldable. In the video that I made and uploaded previously, for some reason the audio did not work on that video, so I'm re-recording it. So, yeah, if you already watched the ridiculously crazy video with the sound that didn't work right, hopefully you didn't stick around too long and realized that that was a bad idea. And now, if you did watch it, I'm sorry, but hopefully you didn't, and you're just watching this one, and so life will be good. So we're gonna start over here in the bottom corner. Um, so this is under the flap that says from an equation. And so we're going to kind of do this out of order a little bit, and I think it makes a little more sense to do it this way. So here goes. So proportional equations must be in the form y equals kx. So proportional equations must be in the form y equals kx. So they must be in the form y equals kx, where k is the constant of proportionality. So up until this point, earlier today, we talked about y equals mx plus b. And so instead of y equals mx, if I have a constant of proportionality, meaning that my m value is the rate of change is constant, and so as long as my rate of change is constant, instead of m, I'm going to use k. So if my rate of change is not constant, then I can use the m, and y equals mx plus b, so m is rate of change. But if it's a constant rate of change, constant proportionality, then I'll use k instead, and k is the same as m. The k is the coefficient of x. And so here we go. We're looking for y equals kx. That's a very important format. And so we have an equation, y equals 10x. And so this is the same as y equals kx, right? So k is 10. And so I'm not sure what's going on with my pen as always, but giving me problems. But y equals kx. So k is 10. That is in the correct format. And so if it is in the correct format, then it is going to be proportional. Second one, y equals 3.2 or 3 and 2 tenths x. And so that is in the right format, y equals kx. So correct format, k is then 3.2 or 3 and 2 tenths. So because it's in the right format, it is proportional as well. Third example, y equals 3x plus 4. Well, this plus 4 here, because I have a b value, so a plus b, so that's going to ruin it. And so I cannot have a plus b, or I cannot have a b value in this. So this would be not proportional. And because it's not proportional, then I cannot have a k. So I can only have a k if I have a proportional, or that constant of proportionality. And so my k is going to be not applicable. Next one, y equals 5/3 x. And so because it's 5/3 x, it's in the right format, y equals kx. So it's in the right format. It will be proportional. And then k is going to simply be 5/3, which is my coefficient of x. The next one, y equals 7 minus 4x squared. Well, we may not know at this point what a 4x squared or an x squared graph looks like, but I will tell you that because I have this constant here, I have this 7, that's already going to ruin it. The x squared is going to ruin it also, but even if we didn't know that, we know that this 7 over here is enough to ruin it. So not proportional, and so k would be not applicable. y equals negative 9x. It's okay that it's negative, but it is y equals kx, so it's in the right format. It will be proportional, and k, my coefficient of x, is negative 9. Next, we'll look right above that. So the section that's from a graph. And so determining it from a graph, it says the graph must be linear. And so I know in some of the classes we talked about that, and maybe we didn't at all, but linear, we see here that we have the word line. So linear simply means that my graph is going to be in the shape of a straight line. So it has to be linear, and very important, it's in all caps and bolded, and it has to pass through the origin. So it has to be linear and pass through the origin, and the origin is represented by the coordinates 0, 0. So it's got to pass through 0, 0. It has to be linear. All right, and then k is the ratio, and we'll see this a lot. K is the ratio of y to x for any ordered pair. So y is the ratio of y to x for any ordered pair, and the ratio must be in the simplest form. So that means I need to simplify my ratio, and then that's how I'll be able to tell. And we'll see that in a minute when we do tables. But most important part is my graph has to be linear and it has to pass through the origin. So we see here the first graph, it is linear because it goes in a straight line, and it does also pass through the origin. It passes through 0, 0, so it meets the criteria. So the first one is proportional, and then as far as k, it's real easy. All we do is we can start at the origin. We see the origin here, so I'm going to zoom in for a second. So there's my origin. And then if I find another point on the line that's easy to grasp, I can see that we go up 2 and over 1, or my rise is 2, and then my run is 1, or my change in y is 2, my change in x is 1. So 2 over 1, again, it has to be in simplest form. So 2 divided by 1 is simply 2. And so my constant of proportionality is going to be 2. So for the second one, we see that it is not linear because it's a parabola. So because it's not linear, it doesn't matter that it goes to the origin. It's got to meet both criteria. So it's not linear, not proportional. And so then k is NA, or I don't have a k because I don't have a constant rate of change. So then my next one is proportional or not proportional. Well, it looks like it is linear, so it meets that criteria, but does not go through the origin. So because it does not go through the origin, not proportional, and so again, not applicable. And then the last one, it is linear. It does go through the origin, so we're good on both tests. So this one is proportional. And again, starting on my origin, my rise, so I'm going to pick a point over here. My rise is negative 2, or my change in y is negative 2. And then my run is positive 2, or my change in x is positive 2. And so rise over run, I have 2 divided by 2, and 2 divided by 2 is 1. Negative divided by a positive is a negative. So then my answer is going to be negative 1. Next section we're going to do is the table section. And then once we've done the table section, then we will do the last top part of the notes. So table section, it says we need to make a ratio of y to x, and this will make sense in just a bit, but for now we'll write it down. Make a ratio of y to x for all ordered pairs So make a ratio of y to x for all ordered pairs, and then simplify. And the exception to this is if x equals 0. So if x equals 0, I don't have to do that one. I can skip it and go right on to the next one. And if all of my ratios are the same, if that is true, then I know it's proportional. And if I have different ratios, or if they're not all the same, so different ratios, then it's not proportional. And K, as we have already said, K is the ratio of y to x in our simplest form. So again, K is the ratio of y to x in simplest form. So we're going to see a couple of examples of how this works. And so here my x value is 0, so I don't have to do that one. So I can move to the next one. And so I have my ratio of y to x. So y is 3, x is 1. So my ratio of 3 to x, or y to x, is 3 to 1, and 3 divided by 1 is 3, so I need to do it in simplest form. The next one is y to x, which is 6 to 2, because my y is 6, my x is 2, so my ratio is 6 to 2, but in simplest form I need to simplify that. 6 divided by 2 is 3, so far so good, but I don't want to give up just yet, I want to make sure. Now my ratio of y to x is 9 to 3. 9 divided by 3 is 3. So again, looks like we are on the right track. Last one, I have 12 to 4. So my y to x is 12 to 4. 12 divided by 4 is 3. And they all match. So this also goes through the origin. My rate of proportion is constant. So we meet all our criteria. This is proportional. And then K is 3 because that's the answer that I've got for all of those. So we're good to go. My formula for this one would be y equals 3x. All right, so the next one, x to y. So I have x is 0, so I can skip that one. And then so now I have my ratio of y to x is 3 to 1. Simplifies to 3. The next one is 5 to 2. And so 5 to 2, well, that's not 3. So that's not going to work. The next one I have 7 to 3. And then last I have 9 to 4. So none of these simplify to 3. So they're changing. They're different. So because it's different, it's not proportional. And so my K would be not applicable. Don't have to worry about that one. The third one, I have my change in y to my change in x, or my ratio of y to x, rather. So my y is -3, my x is -2. Negative divided by a negative is a positive, so I have 3/2. And as we said in class, it's okay to have a fraction, and we're perfectly fine with that. In fact, it's probably preferred, so I can see my rise over run a little easier. So a rise of 3 and then a run of 2, I'm able to see what that rate of change is on my graph, okay? So next one is 6 to 4, so my y is 6 to 4, so my ratio of y to x, 6 divided by 4, well, I can divide top and bottom by 2, and that's going to get me 3 over 2. So far, so good. Let's keep going. Now I have 12 to 8, divide top and bottom by 4, that gives me 3 over 2, and then 18 over 12, divide the top and bottom by, let's see, 6, and that's going to get me, I said 6, divide it by 6, not right, 6, 18 divided by 6 is 3, 12 divided by 6 is 2, so far so good. 24 over 16, divide top by 8, did it again, and then divide the bottom by 8, and so we see they all match. I don't see that I'm going through the origin at this point, but I know that I will. So if I graph it or if I keep going, and I think in one of the classes we actually did go that far, and we saw that yes, it does go through the origin. And so we saw that this one is proportional, and my k, my constant rate of change, or my constant of proportionality is 3 over 2. I'll write that a little neater. All right, and then the last one, my y to x ratio. So I have -2 to -1. That's going to simplify. 2 divided by 1 is 2. Negative divided by negative is a positive, so I have a +2. All right, so it looks like it goes through the origin here, but my x value is 0. If x is 0, I don't have to do that one, so we'll skip it. Now my y to x, 2 to 1. So that is good. We match so far, but we don't want to give up and stop there. We want to keep going. So the next one is 4 to 2. 4 divided by 2 is 2. And so still, so far, so good. But let's keep going. The last value I see 9. So my ratio of y to x is 9 to 3. 9 divided by 3 is 3. So, we don't match. So at this point, we know, nope, not proportional. And because it's not proportional, then k is not applicable. And then for the last portion, we'll do the notes up at the top corner. And so this is just under the flap that says constant of proportionality. And so my constant of proportionality is the constant ratio of y to x. So my constant ratio of y to x. Constant meaning unchanging, right? Ratio of y to x. And that's what we've seen in our equations, our graphs, and our tables. So hopefully it's starting to make some sense. And so in this case, constant means unchanging or at the same rate. So my rate stays the same. That m value, my rate of change, doesn't change. So if my rate of change is constant, then now instead of calling it m, I get to call it k. And so that just makes it a little bit simpler. I know all of a sudden now I have a linear equation. I know that it's going to be our linear graph, and it's going to go through the origin, be proportional. So this letter k gives us a lot of information instead of having just an m and not really being sure of what we're looking at. So this is just a more specific way of notating this special type of graph. And so k, and we said that before, was that it's in the form of y equals kx. And so if it's y equals kx, and here we're wanting me to have k by itself, and so we're going to set it in terms of k. Well, I have k times x. I need to get rid of the x, so k is by itself, so I'm going to divide by x, divide the other side by x. X divided by x is 1. 1 times k is k. So that gives me k equals y over x. And so that's how that equation is derived. And you really can know either one. So you can memorize k equals y over x or y equals kx. They mean the same thing. And depending on what information you have and what you're looking for, you're going to be able to do the same thing with either equation. So they really are the same. And so we know that our constant of proportionality can be an integer, so my k value can be an integer. It can also be a fraction. So we've seen some that are fractions, even improper fractions. Those are good. And then it can also be a decimal. So any of those formats are fine. And if the relationship is not proportional, then there is no constant of proportionality. So if it's not proportional, then I'm just going to write k equals NA, as we've done on several of them. If it is proportional, then I know proportional. If it is proportional, then it will go through the origin. So just a couple things to really remember that's going to kind of help us recognize right away if it is or not a constant of proportionality. So if it goes through the origin and it's linear, then we're good. If it's not proportional, then I don't have a k value, and I can just stop right there. K equals NA, and I'm done. So hopefully this helps. And if you have any more questions, let me know. I also have a completed version of these notes on the notes page on my website as well as Instagram. And other than that, we'll see you guys in class.